Okay, fifth graders, today we're doing Eureka Math Module 2, Lesson 24, and we're going to use what we know about place value to help us divide decimals this time by multiples of 10. You should have already done the problem of the day with your sub. Today you don't need to write steps 1, 2, and 3, but if you haven't yet, please copy down the chart into your notebook and take some time to finish the chart. Pause the video so that you can compare your answers against mine. Okay, I'm going to be completely honest with you and tell you that I just copied the answers from the answer key into the chart because I want to get on with today's lesson. But you should have shown all the 4 division problems in your math notebook. But check your answers, and if it's not quite right, figure out what your mistake was before going on to the next slide. Okay, here we have 3 division problems and a place value chart. Go ahead and draw yourself a place value chart, and let's get started. So our first question, we have 54 divided by 10. Okay, so if I have 54 on my place value chart, it's 5 10s and 4 1s. As you know, if we divide by 10, we are shifting the digits to the right, and because we shifted 1 time to the right, we can see now that my answer is 5.4. The 10s moved, the 5 was in the 10s place before, and now it moved to the 1s place, and the 4 was in the 1s place before, and now it moved to the 10th place, right? Good. Now let's try it now. Let's say I start with 5.4, which is what I have here, 5.4, right? Let's say I want to now divide that by 10 again. Let's see, what would we get? Oh boy, my answers are moving with me. Great. My 5 was in the 1's place, but now we can see it's in the 10th place, and my 4 was in the 10th place, and now it's in the 100th place. So the answer here is 0.54. Okay, now if our new whole is 0.54, right? So our 5 was in the 10th place. Based on the pattern above, we know that actually when I shift the numbers, then the 5 will be in the 100th place, and the 4 was in the 100th place, and now it'll be in the 1000th place. So I expect my new answer to be 0.054, 54 thousandths. Let's try it out on our place value chart. We have 0.54 here, right? And if I shift it, if I divide it by 10, it's going to shift 1 place value to the right. And indeed, my 5 is now in the 100th place, and my 4 is now in the 1000th place. So the quotient is 0.054, or 54 thousandths. Take some time right now to write a sentence or two in your math notebook about how the digits shift and what happens to the digits as you divide by 10. You'll notice that it's not any different than when we were working with whole numbers, yeah? Good, let's move on. Okay, this time let's look at this first problem first. 54 divided by 90. This is similar, we have the same whole as before, 54, but this time we're dividing by 90. So we know that dividing by 90, we can break it apart, right? We can think of 90 as the same as being dividing it by 10 first and then dividing it by 9. This is helpful because in our previous example, we know that 54 divided by 10, we just shift everything over, right? The 5 was in the 10th place, and now it'll be in the 1's place, and the 4 was in the 1's place, and now it'll be in the 10th place. So this is 5.4 now divided by 9. Well, how can I rename 5.4 using unit form? I know that this is the same as 54 tenths divided by 9. And that's helpful because I know math facts 54 divided by 9 is 6, and I'm using the tenths, so it's 6 tenths, or in standard form, 0.6. So I know that this is equal to 0.6, or 6 tenths. Let's try it using the second example. Okay, so I have 5.4 divided by 90. Well, that's the same as 5.4 divided by 10 divided by 9. And if I do this part first, 5.4 divided by 10, I know that's 0.54, right? Because all the digits shift divided by 9. Well, 0.54, that's 54 hundredths divided by 9, right? Which is the same as 6 hundredths, which, written in standard form, is 0.06. So this one is equal to 0.06. Let's follow the same pattern for this last problem. 0.54 divided by 90 is the same as 0.54 divided by first 10, then divided by 9. Yeah? Okay, well, if I take care of this part first, all these digits would shift, right? So the 5 instead of being in the tenths place, would then be in the hundredths place. And the 4, instead of being in the hundredths place, would be in the thousandths place, divided by 9. Well, that's the same as 54 thousandths divided by 9, which is going to equal to 6 thousandths, right? Which is equal to 0.006. I'm running out of room, but you get the point. Okay, here's a challenge for you. See if you can use this reasoning or this logic or this format, this idea, and see if you can do 54 divided by 900 then. Well, it's 54 divided by 100 divided by 9. Do you guys agree that that's equal? I hope so. When I divide by 100, I know that I'm shifting the digits 2 places to the right. So if the 5 was in the tens place, it shifts 2 places to the right. That's going to be in the tenths place, right? It's going to bypass the ones place and move to the tenths place. Similarly, the 4 was in the ones place, shifting in 1 place would move it to the tenths, shifting in 2 places would move it to the hundredths. So let's put it in the hundredths place. So that's the same thing as 54 divided by 100, and then divided by 9, right? Let's rename it using units. This is 54. I have to think to myself, what place value is that? Oh yeah, it's the hundredths divided by 9. So 54 divided by 9 is still 6, but my units is hundredths, right? So I can write that in standard form as 0.06. So the answer to this question is 0.06 or 6 hundredths. See if you can try it, pause the video, and see if you can do the next problem by yourself. Okay, so we can separate out 900, the divisor of 900, into 109, right? So 5.4 divided by 900 is the same as 5.4 divided by 100 divided by 9, which is the same as if I divide 5.4 into 100 equal pieces, I would shift those digits 2 spaces to the right, so it'd be 54 thousandths divided by 9, which is 6 thousandths. As you can see, this isn't that hard, but it's very easy for people to make place value mistakes, because if you don't write out how you're breaking up the divisor, or you don't divide it correctly, or if you don't pay attention to the units that you're working in, then you will make mistakes. So please don't be lazy. It doesn't take that long to write it out, and it's worth it to not make mistakes. Wouldn't you agree? Okay, this problem says that 21 liters of coffee were equally distributed to 30 cups. Okay, the question's asking how many millimeters of coffee were in each cup. So in order to do this problem, we have to first figure out 2.1 liters is equal to how many milliliters. Let's use unit conversions to do this. We know that 2.1 liters is equal to 2.1 copies of 1 liter, which is equal to 2.1, forgot the 1 there, 2.1 liters times some number of milliliters. How many milliliters are in 1 liter? The answer is 1,000. Okay, so we're able to now multiply. Remember, when we multiply, we shift the digits to the left. And because there's 3 factors of 10 here, we have to shift it 3 times to the left, which would make it look like the decimal point is moving 3 places to the right, right? So keep that in mind. Okay, so 2.1 times 1,000 is 2,100 milliliters. But now we have to divide that into 30 cups. So we have to do 2,100 divided by 30, which is the same as 2,100 divided by 10 divided by 3, which is the same as if I divide 2,100 divided by 10, all those digits are shifting 1 spot to the right, so it'd be 210 divided by 3, which, thinking about unit form, that's 21 tens divided by 3. Let me make it a little smaller so I have enough space, which would then be 7 tens, or 70, and my units is milliliters. 5th graders, please do the following problems in your Lesson 24 problem set, then do your exit ticket followed by Zern. Thank you, and don't forget to ask if you have any questions.